Right, today in Algebra 2, we're going to look at the first part of section 3.5, the zeros of polynomial functions. Our essential question: how are the zeros of a polynomial function related to an equation and graph of the function? And after this, you should be able to model and solve problems using the zeros of a polynomial function. Okay. So first, let's start off with some vocabulary. It says the blank of a polynomial function is a value for which the function is equal to 0. Okay. We already know this. This is a 0. And remember that another word for 0 are x-intercepts, solutions, okay, roots. This is where the graph crosses the x-axis. So we are going to start out with using zeros to graph a polynomial function. It says sketch a rough graph drawing a continuous curve that passes through each zero on the x-axis and is below the x-axis when the function is negative and above the x-axis when the function is positive. So number one, notice that it's already in factored form. It tells us f of x equals x, x minus 4, and x plus 3. So our zeros, we get our zeros by solving each of these. So our zeros come from x equals 0, x minus 4 equals 0, and x plus 3 equals 0. It's nice when they give us the polynomial already factored. Okay? So x equals 0, that's our first 0. X equals 4, that's my next 0. And x equals negative 3. I know those are my x-intercepts where the graph crosses the x-axis, so I can go ahead and plot those on my x-axis. So negative 3, 0, and 4. So now we just need to know when is it above the x-axis, when is it below the x-axis. So we're going to come over here and make a little chart. We're going to look at the interval and then the sign of the function. So I need to know what is it doing from negative 3 beyond. So that's when x is less than negative 3. That's my interval I'm looking at. The next interval I want to know between negative 3 and 0. So what is it doing when x is between negative 3 and 0? Then I need to know what is it doing when x is between 0 and 4. That's my next interval. And finally, I want to know what is the graph doing when x is bigger than 4, so x greater than 4. So these are the intervals that we're looking at. So now to find the signs, we just need to pick a number in each interval and plug into our equation. So x is less than negative 3. I'm just going to pick the next whole number smaller than negative 3, and that's negative 4. And I'm going to plug into that equation that they gave to me. So I'm going to replace all my x's with negative 4. So I would have negative 4 times negative 4 minus 4 times negative 4 plus 3. I really don't even need to know what the number is. I just need to know, is it going to be positive or negative? So here, I know that I get a negative times a negative, so I'm at positive. But then this is also going to be negative. So positive times negative, I know that negative, which means I'm below the x-axis here. Now I want to pick a number between negative 3 and 0. I'm going to pick the smallest whole number there, negative 1. I'm going to plug in negative 1, negative 1 minus 4, and negative 1 plus 3. Again, these first two are both negative, so when I multiply them, I get a positive. But then this one here is also positive, so this is going to be positive, so this is going to be above my x-axis. Now pick a number between 0 and 4. I'm just going to pick positive 1, so I get 1 into 1 minus 4 times 1 plus 3. So this is positive, negative, so I'm at negative, positive. So negative and a positive give me a negative. So again, I'm back below the x-axis. And finally, a number bigger than 4, so I'll plug in 5. So 5, 5 minus 4, 5 plus 3. All of these are going to be positive numbers. So this is positive. We are back above the x-axis. Remember we said up here, sketch a rough graph. Okay, so this is a rough sketch. Okay. We're not going to have the y values exact. We're not interested in that. We're just interested in the rough idea of what it looks like. So when x is less than negative 3, I know I'm below the x-axis. So I know this is that. X was greater than 4, I know it's positive above so I've got my end behaviors. I know my end behavior is a down up. I know between negative 3 and 0, my graph was positive, which meant that it was above the x-axis. I can make it go up as high as I want and then turn and come back down. Between 0 and 4, we said it was negative, which means it's below. Again, I don't know how low it's going, and right now we don't care in that. We're just interested in the rough sketch. So something like that. We're just remembering to make it a smooth curve. So that is a rough sketch of the polynomial f of x equals x times x minus 4 times x plus 3. Okay, so that was the first example. Let's do another one of those. So example number 2, f of x equals 4x cubed plus 4x squared minus 24x. Notice this one has not been factored for us, so the very first thing we must do is factor. Yay, 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 right? Okay, so in order to factor this, first let's look for a GCF, the greatest common factor. So I noticed that I could take a 4 out of everything as well as an x, so factor out a 4x. Now I am left with x squared plus x minus 6. X squared plus x minus 6, that looks like a nice, easy trinomial to factor. So I still have my 4x out here, 2 sets of parentheses here, right? X and x. And I'm asking myself, what can I multiply together to get negative 6? Add to get a positive 1. That's going to be a positive 3 and a negative 2. Now we set each of these factors equal to 0, right? So when we do that, our zeros are going to be x equals 0 from 4x equals 0, x equals negative 3, and x equals positive 2. So now we want to plot those on the graph. So negative 3, 0, and 2. Again, now I just need to know what is it doing between each of these spots. So our intervals and our sign. So I need to know what is it doing when my x's are smaller than negative 3. So when x is less than negative 3, what's happening? Between negative 3 and 0. So what's happening when x is between negative 3 and 0? Between 0 and 2. And when x is greater than 2. We want to know what is the sign of the function in each of these spots, and then that's going to tell us if our graph is above the x-axis or below the x-axis. So just like above. All right, so x is less than negative 3. Again, I'm just going to pick negative 4, and I'm going to plug in. So I'm going to have 4 times negative 4 times negative 4 plus 3 times negative 4 minus 2. So I get negative times negative is positive times another negative. We are negative here. So I know this is below the x-axis. So below, I know the first end behavior is a down. When x is between negative 3 and 0, I'm just going to pick negative 1. So 4 times negative 1 times negative 1 plus 3 times negative 1 minus 2. So I have a negative times a positive times another negative. So positive. So I know between negative 3 and 0, my graph is above the x-axis. I don't know how high it goes, and I don't need to know how high it goes, right? Whatever I want it to be, like that. Between 0 and 2, I'm just going to pick 1. So 4 times 1, 1 plus 3, 1 minus 2. 4 times 1 is positive. 1 plus 3 is positive. 1 minus 2 is negative. So that's going to be negative and below the x-axis. And I don't know how low it's going. I can make it go wherever I want. X is greater than 2. So we'll pick 3. So 4 times 3. 3 plus 3. 3 minus 2. We see that this is positive. So we are above the x-axis. There is a rough sketch of our graph. Again, our end behavior was a down and up. All right, we're going to do one more example like this. So on the next page of our notes, f of x equals x to the fourth minus 81. Again, I see that this has not been factored. So again, the first thing we must do is factor. So x to the fourth minus 81. I notice that 81 is a perfect square. And I notice that it's a subtraction. So this is a difference of squares. So I know this is going to factor to two sets of parentheses. Remember with x to the fourth, okay, if it's a difference of squares, right, I'm looking for what can I multiply 2 by to get 4? Well, 2 times 2 is 4, so I know it's going to be an x squared plus and an x squared minus. The square root of 81 is 9. But yet again, what did we create? X squared minus 9 is another difference of squares. So I still have this x squared plus 9 here. X squared minus 9 factors to another set of parentheses, the square root of both of those, so I get an x plus and an x minus. The square root of 9 is 3. These are my zeros. X squared plus 9. If I solved this, right, x squared plus 9 equals 0, I would get x squared equals negative 9. X would equal positive or negative when I take the square root of negative 9. The square root of 9 gets me 3, but the square root of that negative is 3i. These are not real, right? So this graph, or this function, has two imaginary solutions. It doesn't cross the x-axis at those, okay? So my only zeros on my graph come from here, so negative 3 and positive 3. So negative 3 and positive 3 is the only thing that I'm plotting, because the other zeros of this function are not real numbers. So again, I'm going to make my little chart, my interval, and my sign. So I start furthest to the left, negative 3. So I need to know what is the graph doing to the left of negative 3. So that's when x is less than negative 3, what's happening. I need to know what's happening between my two x-intercepts. So when x is between negative 3 and 3, and then when x is greater than 3. Again, how I'm going to figure that out, I'm just going to plug numbers in. So find a number smaller than negative 3, so negative 4. And here, again, I can plug it into the original equation, or I can plug it into where I factored. So if I plug it into where I factored, I have negative 4 squared plus 9, negative 4 plus 3, and negative 4 minus 3. So let's see, I get positive, negative, negative, which turns to positive. So I know that my graph is above the x-axis here. If I pick a number between negative 3 and 3, I'm just going to pick 0. That's going to be the easiest, right? If I plug 0 in, if I plug 0 into my original equation, I get 0 minus 81, which is negative 81. That's negative. So I know I'm below the x-axis. I know it's going way down here because it's going way down to negative 81. And so I know it's way down here. Pick a number greater than 3. So if I plug in 4, 4 squared plus 9, 4 plus 3, 4 minus 3. I see all of that is going to give me a positive number above the x-axis. So this would be a very rough sketch of what this graph would look like, x to the fourth minus 81. All right, the next thing that we want to talk about is understanding how a multiple zero can affect a graph. It tells us the multiplicity of a zero of a polynomial function is the number of times its related factor appears in the factored form of the polynomial. And then it says, what can you conclude about the multiplicity of a zero and its effect on the graph of the function? So let's look at these graphs that I've provided here. This first one, I already put it in factored form. F of x equals x minus 1 and x plus 2. They each only appear one time. I get the 0, positive 1 and positive 2. What's happening at both of those? Okay, so it appears once. and at both of them it crosses through. This next one, x minus 1 quantity squared, this one appears twice. X plus 2 appears once. When I solve x plus 2, I get negative 2. It appeared once. It's crossing through. This one appeared twice. Notice that the graph turns. It touches that, but it doesn't cross through the x-axis. It turns and goes back up. This next picture down here, x minus 1 quantity cubed, it appears 3 times. That gets me a positive 1 when I solve it. X plus 2 gets me a negative 2, only appears once. So I cross, I go up, I cross a little bit, and then turn and come back up. This next one, x minus 1 to the 4th power, gives me x equals 1. Notice that it's not crossing the x-axis, it's turning and going up. X plus 2 only appears 1 time, and it crosses through the x-axis. So when the multiplicity of a 0 is when it is odd, we'll start with odd. So we're talking about it appears an odd number of times, so like it only appears 1 time, 3 times, 5 times, 7 times. So up here, this appeared once, this appeared once. It crossed. Okay? This appeared once, it crossed through. This one appeared 3 times. That's odd. It crossed once, it crossed. This one appeared 1 time, it crossed. So when you have a multiplicity of odd, the graph crosses the x-axis. My only other option, if it's not odd, it's going to be even. We had that here, x minus 1 quantity squared. And notice that here the graph came, it touched that 0, and then it turned and went back. Here it did the same thing when it appeared 4 times. So an even number of times if it appears twice, 4 times, 6 times, my exponent is, an even number, then it touches and turns back up. So the graph has a turning point. It's a turning point at the x-axis. Okay? So really that just means it touches and turns back. Does not cross here. Does not cross here. Okay. All right, so multiplicity of a 0, again, that's how many times it appears. You're looking at your exponent of that factor. If the exponent is an odd number like 1, 3, 5, 7, 9, 11, your graph is going to cross through the x-axis at that 0. If your graph, the factor has a multiplicity of a even, so the exponent is like a 2, so it's like quantity squared, quantity to the 4th power, to the 6th power, to the 8th power, then our graph has a turning point at that factor, at that 0, which means that it touches at that 0 and then turns and goes back up. It does not cross through the x-axis. All right, so let's practice that. The next one, it says describe the behavior of the graph of the function at each of its zeros. It's already in factored form for us, so this is nice. So this first one, x equals 0. Okay. Notice my exponent is a 1, so that's odd. Right? So it crosses the x-axis here. So it crosses the x-axis at 0. My next one, I have x plus 4 equals 0. Notice my exponent of that factor is just 1. So again, that's odd. So here it also crosses the x-axis at, if I solve that, I would get negative 4. X minus 1 to the 4th power, that's even. So I have this factor that appears 4 times. That's even. That means I have a turning point. Turning point. So the graph touches at 1, then turns back. It does not cross the x-axis at positive 1. Let's look at number 2, x squared plus 9, x minus 1 to the 5th power, x plus 2 quantity squared. X squared plus 9. Okay, so let's talk about that. Let's first solve this. X squared plus 9 equals 0. We had this earlier, so I would get x squared equals negative 9. X would equal, when I take the square to both sides, I would get positive and negative 3i. That's imaginary, not real. So nothing, that doesn't affect my graph in any way. Okay? Those are just two imaginary or complex solutions of the polynomial, but it doesn't have anything to do with the graph itself. So then I'm going to go to x minus 1 to the 5th power. Okay, that 5 is odd, so that means that this graph crosses the x-axis at 1. Then I have x plus 2 quantity squared. This is even because it's a quantity squared. So that means I have a turning point at negative 2. So at negative 2, my graph touches the x-axis at negative 2, but then it turns and it goes the exact same direction that it came from. All right, let's go to the next page of notes. We're going to do the front side of this, and then that's where we'll stop for the day, and then we'll pick back up with this tomorrow. So find real and complex zeros. What are all the real and complex zeros of the polynomial function shown in the graph? So they give me the function f of x equals x cubed plus x squared minus 3x minus 6. Okay. Notice that this graph only touches the x-axis one time, okay? But my degree is a 3. The degree of your polynomial tells you how many zeros you have, okay? So let's write that down. So the degree equals the number of zeros I will have. So third degree means I have 3 zeros. They might not all be real zeros, as in this case, I can see that it only crosses my graph one time. So I know I'm only going to have one real zero here. The rest are going to be complex. So I get my real zero from the graph at x equals positive 2. So now how do I find out what my complex zeros are? I have to have this factored, okay? So we want to factor this. The nice thing about this, I already know one of them, one of my zeros is 2. Remember when we did synthetic division and we did the remainder theorem, the factor theorem, which told me that if my remainder was 0, that was a factor. I know that 2 is a factor, okay? So I'm going to do synthetic division, and I'm going to find what is the rest of this polynomial after I take the 2 out. So put 2 in my box. I check to see if I need any 0 placeholders. I have x cubed, x squared, x constant. I don't need any zeros. So remember synthetic division, we write down our coefficients. So 1, 1, negative 3, and negative 6. My first number always comes straight down. Remember, below the line, I multiply with my box. So 1 times 2 is 2. Above the line, I add. 1 plus 2 is 3. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 2 is 6. Negative 6 plus 6 is 0, which we expected because we knew by looking at this graph that 2 was indeed a factor. Also now, remember from synthetic division, these are my new coefficients. 1 degree less than where I started. I started with x cubed, so I've got an x squared plus 3x plus 3 equals 0. So that's what I get when I factored out the x minus 2. Okay. So this polynomial factored right now is x minus 2 times x squared plus 3x plus 3. We know x squared plus 3x plus 3 is not going to factor, because if it did, we would see other zeros, other x-intercepts on our graph. So I need to either make this factor by completing the square, or I can solve using the quadratic function. Okay? You all know me. I prefer to complete the square over quadratic function. So, and I also think this is a nice time to review completing the square. So I'm going to solve this by completing the square for us. So complete the square. I need to move that 3, the number that's not the perfect square, to the other side. So I get x squared plus 3x plus my blank equals negative 3 plus my blank. I take the number in front of x, I cut it in half and square it. So I'm just going to, over here, 3 cut in half, squared. That's how I find the number I add to both sides. Since it's a fraction, I have to square both top and bottom. So when I square that, I get 9/4. So I'm adding 9/4 to both sides. This left side, I just made a perfect square, so quantity squared. X plus, because that was plus, this is plus. This number cut in half, so 3/2 equals negative 3 plus 9/4. Yay, fractions, right? So I need to get a common denominator. Right now I have negative 3 over 1 plus 9 over 4. I need a common denominator of 4. So I need to multiply this by 4. So on top I get negative 12. So negative 12/4 plus 9/4 gets me negative 3/4 over here. Okay. This now is what we want to solve. If x plus 3/2 quantity squared, I need to get rid of quantity squared, so I take the square root of both sides. So now I have x plus 3/2 equals, I put the radical in the problem, so plus or minus the square root of negative 3/4. Remember, I can break that down to the square root of negative 3 over the square root of 4. On top, the square root of negative 3. I can't do the square root of 3, but that negative comes out as an I, so I have I square roots of 3 over the square root of 4 is 2. Now to get x by itself, I just have to subtract 3/2. So I get x equals, I always put my real number in front. Remember, standard form of a complex number, so negative 3/2 plus or minus I square roots of 3 over 2. Those are my two imaginary or complex solutions. My other solution was x equals 2. So over here, I'm going to write down all of my zeros. I get x equals 2 and x equals negative 3/2 plus or minus I square roots of 3 divided by 2. So when you're listing your zeros, don't forget about the one that you got from the graph, the very first one that you started out with, that you did synthetic division from. We're going to do a few more examples like that. So example number 2, 2x cubed minus 8x squared plus 9x minus 9. Again, I see it's a third degree. I know I'm going to have 3 solutions. I'm going to end up with 3 answers. Okay? I can get one of them from the graph. I have one of them that's real. So I know one of my answers right now is x equals 3. I'm going to do synthetic division. 3 goes in my box. I check my polynomial. I go from an x cubed to an x squared to an x to a constant. I'm not missing anything, so I don't need any 0 placeholders. So put my coefficients 2, negative 8, 9, and negative 9. My first number comes straight down. Multiply, 3 times 2 gets me 6. Add, negative 8 plus 6 gets me negative 2. 3 times negative 2 gets me negative 6. 9 minus 6 gets me 3. 3 times 3 is 9. We knew that was going to be a 0. Okay? Because the factor theorem told me that if my remainder is a 0, it's a factor. And we knew that x equals 3 was a 0 because it's crossing the x-axis. Now remember, these are my coefficients. So my new polynomial, 2x squared minus 2x plus 3. This is what I want to solve. I know it's not going to factor because looking at my graph only crossed the x-axis one time. So I know that my other 2 answers are going to be complex numbers. Okay. On the previous example, I completed the square. Notice this one, I have a 2 out in front, right? I cannot complete the square when I have a number out in front. I would have to get rid of that number out front. So this one probably going to be a little bit easier to do quadratic formula. And I want to give an example of quadratic formula to remind you guys how to do that for those of you that prefer quadratic formula. So this one we will solve with quadratic formula. So quadratic formula, x equals, I can write down my a, b, and c. So a was 2, b negative 2, c 3. So quadratic formula, x equals negative b, just change the sign of b, so 2 plus or minus the square root, b squared, so negative 2 squared, minus 4 times a times c, everything divided by 2 times a. So now we want to work that out. So x equals 2 plus or minus. Underneath the radical, negative 2 squared is 4. 4 times 2 is 8, times 3 is 24, so I have 4 minus 24, everything divided by 4. I see underneath my radical, I'm going to have a negative sign, which we expect, because we know these are going to be complex numbers or imaginary solutions. So I have 2 plus or minus the square root, negative 20, everything over 4. Negative 20. Okay, remember I have to do factor tree on this. Okay, so I'll come over here, 20. If I do factor tree, that's 5 times 4. 4 is 2 and 2, so I'm going to have a 2 that comes out. So x equals 2 plus or minus the square root of 20. The 2 comes out. The negative comes out as an I, so 2i. Square roots of 5 left behind. Everything over 4. But now I see I have a 2, and a 4, so I can simplify that. Remember, if we can reduce and simplify, we have to do that. So that equals this 2 and this 4, they cancel, right? Leaves me a 1 on top, plus or minus this 2 also becomes a 1i, square roots of 5. We're left with a 2 in the denominator. So my 3 solutions are x equals 3, x equals 1, plus or minus I square roots of 5 over 2. Those are my 3 solutions to number 2. All right, let's look at one more for today doing this. So f of x equals x to the 4th minus 3x squared minus 4. Notice it's a 4th degree. So that means we will have 4 solutions. It's nice. I have 2 of them for my graph. So I know x equals 2, and I know x equals negative 2 from my graph. My other 2 are going to be imaginary. So, again, synthetic division. It doesn't matter whether I start with a positive 2 or the negative 2. I'm just going to start with my negative 2 because it's furthest to the left. I go back to my original equation that they gave to me. I notice I'm missing an x cubed and an x, so I need 0 placeholders. So I'm going to have 1, 0, negative 3, 0, negative 4. Drop my 1 straight down, so I get negative 2. Add, multiply, add. We knew that this was going to give us a 0. This is my new polynomial. Right? This is x cubed minus 2x squared plus x minus 2. We would have to factor that, but I don't really have to factor it because remember up here I already know another 0. So I can do synthetic division again on these coefficients with the other 0 that I didn't already use. So now I'm going to use the positive 2 synthetic division with these coefficients. 1, negative 2, 1, negative 2. So bring my 1 straight down. 1 times 2 is 2. 0, 0, 2. Again, I knew I was going to get the remainder of 0. So now I have a 1x squared, 0x, okay, and then plus 1 equals 0. I don't have to factor this. I don't have to complete the square. I don't have to quadratic formula because I don't have an x term. So I can very easily solve this and just say x squared equals -1. Take the square root of both sides. X equals positive and negative. The square root of -1 is I. So here are my 4 solutions. X equals positive and -2. X equals positive and -I. All right. That is day 1 of section 3.5. I know that's a lot. As of today, when I made this video, there was no online Envision assignment available to us. I know that's breaking your heart. I can hear you crying all the way in California. So your homework is not on the computer. It is a worksheet. You can find the worksheet in the announcement in Canvas or also underneath the assignment tab. It will say 3.5 worksheet. The numbers that you're going to do today are listed in the announcement. So go ahead and do that first page of 3.5, the first assignment that I gave to you. Hold on to that. When I return, I will pick it up and grade it. Tomorrow we will finish 3.5, day 2. Best of luck to you all. Miss you.